Okay, similar to what we have done in the example, you can show that for any polynomial function in this form, or you can write it as a sub n times x to n plus a sub n 1 and minus 1 times x to n minus 1 plus a1 times x to power 1 plus a0 times x to power 0. And we can show that such a polynomial is always a big O x to power n. So it has an upper bound of growth, which is x to power n. Obviously, if you increase this power here, for instance, if f of x is a big O x to the power n, and m is a number greater than n, f of x will also be big O x to power m. Well, as for instance, as we have shown, x squared plus 2x plus 1 is big O x squared. It's also big O x to power 5, naturally. Here's another small example. 7x squared is big O x squared. You can show this as we have done earlier. But it is also big O x to the power 3. Is it the other way around also? Is x cubed, this function here, is it big O 7x to the power 2? Now we know that it is big omega 7x to the power 2 by definition, but is it big O 7x squared? To answer this question, I have to answer the following question. Is there a k, a threshold k, and a constant c such that for all x greater than k, this threshold, x cubed is less than or equal to c times 7x squared? Now, can I find such a k and c pair that satisfies this for all x exceeding k? Now, if you divide by x squared both sides, well, x squared is, except when x is 0, it's a positive value, so I can divide both sides by x squared, and I can ignore the case where x equals 0 because it's just a singular case. And this means I have x less than or equal to 7c, and this should hold for all x values exceeding some k. So can I find a kc pair? And when x is greater than k, x will be less than or equal to 7 times c. Now it is impossible to find such a kc pair because think of any k value, any c value you can think of, 7 times c, at the end of the day, it's going to be a finite number, and you cannot satisfy x less than or equal to 7 times c, a finite number, for any x greater than k. So it's not possible, which means x cubed is not big O 7x squared. Okay, so x squared is big O 7x squared. We can show this. It's simple. You can just select k as 0 or 1, and c is directly seen here as 7, or you can use c as 1. This means 7x squared is big omega x squared, because x squared is big O 7x squared, means 7x squared is big omega x squared. Okay, and for all x greater than 0, x squared is less than or equal to 7 times x squared. So this is your function, let's say f of x, less than or equal to c times g of x. G of x is 7x squared in this case, and c you can just select as 1. And now what we have seen is 7x squared is big O x squared, and also 7x squared is big omega x squared. Therefore, we say that 7x squared is big theta x squared. Now, this shouldn't be surprising, actually, because, well, 7x squared is in the order of x squared. It's no surprise that it's in the same order, because 7, well, you disregard the multiplier here, because it can be absorbed into this constant c. Therefore, some constant times x squared, it will always have the same rate of growth with x squared. Now, some further results here. If f1 of x is a big O g of 1x, g1 of x, and f2 of x is a big O g2 of x, in this case, the sum of f1 and f2 is big O, the maximum of g1 and g2, because, well, f1 is upper bounded by g1 asymptotically, f2 is upper bounded by g2 asymptotically. When you add them up, it will be the maximum of G1 and G2 when what bounds F1 plus F2, because one of them, if they are of the same order, they will have the same bound. If one of them is more dominant, then it will just manifest itself as X grows. On the other hand, if you multiply them, F1x times F2x, then this will be big O G1 of x times G2 of x.